suppose we get started. So thanks for coming. So we're in fact two people to give this tutorial, not the three who are here, but we are three people who've been building these tutorial materials. This is the third conference in which we've shown this tutorial. So the first time was LinuxCon, ContainerCon in Berlin last October, and then DevConf in Czech Republic in January, and now here. Sorry. So I'm Michael Bright. I work for HPE, Hewlett-Packard Enterprise, and I run a local Docker user group in Grenoble in France. And well, maybe I should introduce Haïkel. He hasn't got a mic. So Haïkel works for Red Hat. I think you're a release maintainer for EDO, which is the Red Hat's OpenStack upstream project. Got it. And also Haïkel's a co-organizer of the Docker meetup in Lyon in France. Okay. Just a first thing, I'd put together a sort of setup page on GitHub and sent a mail. I was hoping people might, I see some people have looked at that and some people have installed software in advance. If you haven't, it's not a problem. There are different ways of running the lab, and we'll look at that. I was copying software onto a USB key here, but had to stop as it was slowing my machine down too much. Just one thing which I think can be interesting before we start. Oh, I can't. Okay. I put up here the address to a survey on SurveyMonkey. If you wouldn't mind just filling out, I think, about 8 questions. It just tells us a bit about what your experience is with Docker itself, with Docker Swarm, with Kubernetes, with Apache Mesos, what your experience is, which one you'd like to work on most, and which interests you the less. I mean, we will cover all 3 anyway. I think it's interesting to see the 3 different orchestration engines. There are others than those 3, but those are the most widely used ones today, I would say. Okay, so if you wouldn't mind going and filling out that survey, that would be nice. All these materials are online, currently on a branch specifically for PyCon 2017. I'll merge those into the master at some point after the conference. And these slides are in theory online. I actually need to give a better link to those, and I'll put up a PDF afterwards. Okay. So we'll look at these 3 container orchestration engines, both in command line usage and also using Python bindings. So Docker has Python API, which is maintained by the Docker project itself. Kubernetes has an incubating project, client Python, providing an API, binding onto the Kubernetes API, so as it's version 2.0. It's fairly up to date. Apache Mesos itself doesn't have Python bindings, but there is Python bindings to the Marathon framework, which we'll be using. Okay, so in 2 hours, you're not going to become an expert, but I think you get an interesting overview of these different technologies. Oh, that's a copy. Okay, so the environment, it's a bit tricky. You know, there are advantages to having you run this on your own laptop. Then you have everything locally. You can run it again after the lab. Alternatively, run it in the cloud. Maybe you'll have access afterwards. But the environment changes. So what I would recommend is certainly for the Docker Swarm parts, either use Play with Docker. So there's this site, playwithdocker.com. Let me just I'll come back to that. My machine is is really suffering this afternoon because we've done with the reboot before we started. So playwithdocker.com is a website. It's actually done as a hack about 9 months ago, which allows you to experiment with Docker and even Docker Swarm, creating a whole swarm of up to 4 nodes. It's really very nice to be able to play with Docker without having to install anything on your machine. Or alternatively, on your machine, either using Docker itself installed locally, and Docker Swarm and so on, or under a Docker machine. And then there's also the possibility of running in different cloud providers. We'll try to help you with that if you want to go that way. Okay, so the same for the Docker and the Python modules, just use the same environment they use for the command line stuff. For Kubernetes, probably best is if you run Minikube on your own PC. Can I just ask, who has installed any software? It's going to take too long to look at the survey. Okay, so we'll distribute USB keys to get you started. Actually, do you want to start doing that now? And so you have 2 master keys and 1 USB drive. On the keys, I'm not sure about the drive. There's a directory PyCon downloads. It's about 6 gigabytes if you take everything. You can if you want, but there's stuff for Mac OS, for Windows, and for Linux. So you might just want to select the subdirectories of interest. I've also put Docker images on there. And I had a script to actually pre-charge the images, but I'm not really, it's not ready really to be used. There's one of the notebooks that we use that says explicitly how to use that, but the others I haven't managed to do that yet. But that can be interesting because I don't know, yeah, we're all on Wi-Fi, so if we're all going to be pulling Docker images, we won't get very far. Okay. As we go through, I'll see, there's no way we can write up, is there? I'll put something up here saying how to use the script at the appropriate moment to pre-charge the images into your environment. Okay, so Kubernetes, I'm saying the best is to use the Minikube utility. So that is on the keys on the drive for Mac OS, for Windows, for Linux. With that, you will need Vagrant and VirtualBox, okay, which are also on the keys. Alternatively, you could use Google Cloud. I can look up the instructions for how to create your cloud if you have an account on Google Cloud Platform. Oops. If you don't have an account yet, I think when you sign up, you can get probably $100 or something of free credits. So that could be an option. Okay, Kubernetes Pi, then use the same environment, obviously. For Mesos, so we propose to use Mini Mesos. Yeah, actually that's a quick download, which itself is very small, but then there are some Docker images behind that, which actually are on the keys. I forgot what I wanted to say about the Mesos. Okay, it takes time because of the time to stabilize, or? Okay. Okay, so when we get to that, we'll advise you on setting up of Mini Mesos. Okay, and I've written Mesos Pi, so as I said, it's actually, there's a Python module to Marathon, not to Mesos itself. Okay. There's more repeating. Okay. So we'll generally it will be you alone doing things. We have notebooks that describe the steps to go through. Periodically, so we'll present Docker Swarm, then you do Docker Swarm labs, then we'll present Kubernetes, you do the kind of Kubernetes labs and so on. But feel free, if you want to stay on the subject or move ahead, then obviously you've paid to be here, you're free to use the time as you wish. And thanks to help colleagues who have problems, obviously we'll get around and try and help you, but we're only 2 of us and 20, 30 of you. Yeah, another thing is contributions are welcome. We've put this on GitHub and we're evaluating it at each time. But we're really interested in feedback, things that work, don't work, or more positive things like opening issues, doing pull requests, or whatever. So things we might want to add, it might be just a matter of clearing up the documentation, making things easier to follow, pointing out bugs or actually proposing bug fixes or new features. There are other orchestration engines that we could add into a lab like this. We're using command line or Python bindings, but maybe going forward it would be interesting to have other language bindings like Go in particular. Other tools, graphical interfaces even. If time allowed, I would have added some graphical interfaces to all this. Okay, I'm going to skip through to... Okay, so what is container orchestration? Obviously with Docker or other container engines, we can launch container one at a time, but it wants a way of being able to build up complete solutions, which might be a 3-tier web application, for example, a load balancing proxy, web front end, and then database back end, for example, and you might have multiple instances of some of those tiers. So container orchestration is all about specifying that architecture, how those elements of your solution are linked together, and being able to scale them up, scale them down based on the charge coming from your network. And it's being able to adapt to faults such that if a node goes down, other nodes can accommodate the charge coming from the network. So the 3 orchestrators that we have all have this same basic form at this level of some sort of master node, which is managing the cluster and electing a leader. So there will be one master that has the master view, if you like, of what's going on, and he will distribute tasks to the worker nodes. Okay, and that general model is common to these 3 orchestration engines, and each of them will have some sort of distributed cluster configuration mechanism, like Zookeeper, used to determine who is the leader amongst the masters. Okay, so you typically have 2n plus 1 masters, where 1 is the leader, and if for some reason he can't be contacted, the other masters amongst them have to decide, okay, who is our new leader? And actual workloads will run only, obviously, well, no, actually that isn't true. Workloads will run on the worker nodes, though in some models they might also, the master nodes can operate as worker nodes as well. I think, for example, Docker Swarm, Docker Swarm, the master nodes are also worker nodes. Terminology might change. Let me see. Mesos talks about master, excuse me, master and agent nodes, I think it's the terminology. Okay. And one of the main principles about orchestration is we're talking now about scaling applications. It may no longer be just 3, 4, 5 containers that are being used, but we might be talking about thousands of nodes, with each tens of or hundreds of containers on them. So we can't anymore have a single operator who can go in and correct a particular node. We need something that's automated, and it's something that has to work in terms of desired state. Okay, so we tell the system, okay, I want, for example, 100 web servers, and then it's up to the orchestration engine to make sure that that condition is always satisfied. If a node goes down and it takes down 10 of your web servers, then the orchestration engine has the task of making sure that 10 new web servers are started on other nodes. Okay, so if we look at the main choices, as I say, we'll talk just about Docker Swarm, Apache Mesos, and Kubernetes today. But you should know that there are other choices. Probably the main ones there are Nomad from HashiCorp, Container, and Morpheus. These are things that we haven't integrated into this tutorial so far, but maybe in a future version, or maybe you will do some pull requests to us. I can dream. Okay, and this is just for fun, saying, okay, if you look on Google Trends, if you look for Docker Swarm, Kubernetes, and Mesos, actually it's a little out of date, probably dating back to January. We can see that it's really Kubernetes that has a lot of mindshare. That said, I think we can expect Docker Swarm to pick up a lot more. I should really update that, actually, see where we're at. But these three container orchestration engines, they all have their strengths. I think we can say that Docker Swarm is maybe the one that's the easiest to use, easiest to pick up. You see, it's very easy to just create a swarm. We see that very quickly. Kubernetes is more complicated to use, but it's very extensive in features, and it has an enormous ecosystem. Excuse me. And Apache Mesos it certainly has the steepest learning curve, but today it's the one that is really proven in production. It can deploy not just containers, it's used for a lot of big data, Hadoop, Cassandra type applications as well, Spark, but also containers. And it's something that has been deployed in 1,000, even I think 10,000 node cluster configurations. So that's pretty amazing. I mean, there are people like, thank you, Airbnb, eBay, Twitter, I think PayPal. There are some very big users of Apache Mesos, so do consider it as well. Okay, so if you look at Docker Swarm, so basically Docker Swarm, in fact Swarm mode, because Docker Swarm itself existed as a separate tool since 2014. But since last year, the Swarm functionality was integrated into the Docker container engine, and that really has simplified the usage. And it's meant that now orchestration is directly linked to the Docker engine, which is getting more complicated as we move on, because Docker itself, well, there's now the Moby project, and the upstream has been split into run C and container D and so on. But certainly from a user perspective anyway, we use the single Docker command line client to control all of that. Okay, so Docker Swarm has the same basic architecture that I showed, with this set of masters, set of worker nodes. Each of the worker nodes is running a Docker engine. And although it's not shown here, in fact, a master can operate as a worker node as well. One particular nice thing about Docker Swarm is that they have a mesh network as well. If you try to connect a service on any of the nodes. If the service you're trying to reach isn't on that particular node, then your request is routed automatically through to the node that is running your service. I mentioned it's very easy to create a Docker swarm, and this is introduced in the Docker 1.12 version, which is from last June. We've moved on quite a bit from there, but okay, this was the first time that we had Docker swarm in the engine. And to create a swarm, it's sufficient to do a Docker swarm init. And from then on, you can start doing Docker swarm join on other physical or virtual nodes to connect into that swarm. Very easy. Okay, so in this lab, we're going to look at creation of a 3-node cluster, running a service on that, scaling it up in terms of number of replicas, show how we can do a rolling update of the service, and also show how we can drain a service. So when you want to take out a node for maintenance, the clean way to do it is first to drain that node of any running services. Okay. I had my browser crash just before we started. I was copying these gigabytes onto my USB key, so I lost most of my context. See, slow. Oh, okay. That's better. Okay, so this is the repository on GitHub, Container Orchestration /labs, if you want to recuperate that. And from there, we will actually use the branch Okay. Okay. So it was for this address for the survey that I sent the email. Yeah. Yeah. Sorry. So I normally use Chrome, and I can do these things much faster. Okay. Okay, that's actually the largest I can make it. That's the largest. I'll show you later, maybe after the break, just what people put. It can be interesting to see people's different experience. Is that okay? Can I take that off? Yeah. Okay. Okay. Oh yeah. That took so long, but yeah, I wanted to show you the play with Docker. This network is very slow. Yeah, don't hesitate if you need help. Okay. Pardon? It's not complete that one. Okay. Okay, so I'm going to show you some notebooks of. Sorry, first thing. So, in preparing the lab, what we used was the Jupyter notebook. Do people know the Jupyter notebook, by the way? I just find it interesting as a way of preparing a tutorial because you can, in the notebook format, you can then rerun your whole lab and check that everything's working quite simply. So Jupyter notebooks are directly readable on GitHub. Let me just point out, so I'm under Container Orchestration Labs. I'm on this branch, which is PyCon US 2017. And I've gone into Orchestration Docker Swarm. Okay. It's loading the notebook. It's progressing. Actually, So sorry about this, I need to restart before I can show you the notebook. Okay. Okay. So I don't want to give a lab on Jupyter Notebook, but just to show people who don't know the Jupyter Notebook, essentially a web-based environment. This is a derivative of what was initially the IPython project, if you know that. And Jupyter is basically the multi-language front end on that. And so I used it to prepare some of these tutorials, some of them in command line and some of them in Python. Okay. And this, when it loads, is what a notebook actually looks like. It's actually a series of cells of markdown and code cells of code we can actually execute. And so if you can get to that GitHub site into the branch and get to this Docker Swarm notebook, you will see this notebook like this, which is directly viewable on GitHub and will show you the steps to go through to run the lab. Obviously, the actual steps can be, you might need to adapt them whether you're running locally or whether you're using Play with Docker, for example. So I'm in this example, I'm running locally. I'm running under Docker machine. Again, maybe people don't know Docker machine, but Docker machine would allow you to create virtual machines either locally, typically under VirtualBox, or in a cloud provider, Azure, cloud, Google Cloud, and so on. And it can be very useful for just setting up a virtual lab, multi-node environment. So I'm going to run through this notebook. So the notebook actually has markdown cells, which provide some descriptive about what we're doing. They have code cells, and in this case the code, because this is the command line tutorial, the code is running bash. Okay, it's actually shell commands. And then when we execute a cell, it will show the output locally. Excuse me. Okay, so I'm just setting a variable machine driver to VirtualBox. That's what I'm going to be using to create my virtual machines. Actually, given the time, I was going to clean up, but I think I'll just use the existing machine. Oh, no, okay, no, I'd better clean up. Okay. Okay, I'm going to just quickly go through some steps why I actually initially delete the machines I have on my system. Okay, so you can see up top here, I had 4 machines, actually one of them running on Azure, and 3 of them for this tutorial, Swarm Master and 2 Swarm nodes. And let me just check. Okay. do this manually. Be better. Okay, so I'm going to do a Docker machine create of my first Swarm master node. Takes a minute or so, okay. Yeah, I can see I'm having networking issues, but I shouldn't need the network. Okay. So I just to show you, so previously I had 4 machines, and now I've only got the one, the Azure one left. I deleted the other ones, but I just wanted to start this creation going, as it takes a minute or so. So what you need to do if you're running on your local machine is a Docker machine create of this SW master 1. To be part of the swarm, do you mean? So we will run the swarm init and swarm join commands in a moment. Okay, that's fine. I was getting some error messages about connectivity here, but I see the machine was created fine. So I'm now going to create my first worker node. So it's again Docker machine create. I specify it's a VirtualBox driver, and I call my node SW node 1. My intention is just to show you the start of this, but then have you follow along on the notebook. Okay, so that'll take a minute or so. And let me just show you, it's mentioned in the notebook, but if I do a watch on Docker machine, something is very slow on my machine. Okay. So we have the master we'd already created, and then, okay, it's now created the SW node 1. What I wanted to show you was that there often will be errors as the machine starts up, but if you let it run to completion, it should be okay. If you are using Play with Docker, then you won't need these steps at all. Okay, I launched the next one, and we should see in a moment it appear here. Okay, so it's showing an error already, which hopefully isn't a problem. It just takes a while that it goes through the various steps. Okay, I'm going to go back here, see if I can connect to Play with Docker. Okay, if I'm not too late now. Ah, okay. Sometimes they put these capture tests on. Try again. Okay, the networking is awful, so I can't. Okay, so I see that's created some errors, but maybe we're okay. Yeah, it looks like we're okay. Okay. So I've created 3 nodes. I'll go through the steps until a swarm init at least, and then I'll try and get you started. Though I guess everyone is having problems connecting to internet right now, so that's going to be a problem. Okay, so I created these 3 nodes, SW master 1, node 1, node 2. If I do Docker machine config on SW master 1, it shows me the parameters that we can pass. Okay. Maybe they're not in this room, but it seems there are a couple of hotspots. Christopher's iPhone and Marky's iPhone. If it's someone here, if you could stop.
You have enabled Wi-Fi hotspot on your phone, please disable them because it's interfering with everyone's. That's the origin of the issue. Thank you.
Let me just. So, if you do Docker machine config with the name of one of our nodes, it will give us the parameters that we can pass to the Docker client to be able to contact directly that machine. Or similarly, we can get that in the form of environment variables with Docker machine env on the name of the node. Okay. So here, for example, if I want to look at the networks, before we create a cluster, I'll do Docker, and then in backticks, essentially this Docker machine config swarm master. So it's going to be passing through these parameters. Okay. So if I do that with network ls, this Docker network ls is asking our swarm manager what are the networks it has. Similarly, Docker machine IP will tell us the IP address of the particular node. So our master, if we look, it's 192.168.99.100. And we can look at the info command of this host to see what is the state of its swarm. Where we just created the machines, we haven't created a swarm yet. So it should be no surprise that we get swarm inactive. That Docker swarm info actually is a lot of information. That's why I put the grep on there. I just to show you. So Docker info is all this about the containers and the images available in the host. So that's why I did a grep on Swarm here. Okay, so the actual creation of a cluster of Swarm nodes is this docker swarm init command. So it looks a rather long command because again we have this docker machine config to pick up the parameters of our master node, and we also have this advertise address. So we're just telling it essentially what network interface to use, because this swarm master will be listening for other nodes that want to join our cluster. So if I do a swarm init, so it tells us our swarm is being initialized, and it also provides us a command that we can run on any other node as long as it has network access to our master. Then by running this docker swarm join with this security token, then we can connect that new node into the cluster, in this case as a worker. Okay. There's another token that we can use to connect as a master. Okay, so once we've done that, if I do that docker info again and I grep on swarm, we should see now swarm is active. And we'll see as well, previously we had just 3 networks, the bridge, the host, and well, none. And now that we've initialized the swarm cluster, then we see some other networks have been created. In particular, this ingress overlay swarm network. Okay, so that's actually a VXLAN network which is used to communicate between the swarm nodes. Okay, so now, so remember we have 3 nodes, swarm master and our 2 worker nodes. The token that it gave us earlier, we can actually pull that out as a variable. So here I'm essentially doing it's a docker swarm join token worker command, which is pulling out the information. Let me pull that out in different pieces so you can see a bit more clearly. So it's essentially this command that we want to run to see what is the token to be able to join a node as a worker. Docker swarm join token worker. But I insert first this docker machine config to get the appropriate parameters. And that will give us all that text that we saw earlier. If we add the -q option, then it's just going to give us the token itself. Okay. So if I do worker token equals backtick, so that we can pick up the token, and then we can use that in a docker swarm join. So again, they're actually very simple commands, but it's just that using backticks makes them look rather complicated. Yeah. Okay. So, Docker itself, you have the Docker engine, which is going to create containers, and you're going to run that typically on either a physical machine or a virtual machine, maybe under VirtualBox, maybe in the cloud. Docker machine is just a way of creating multiple virtual machines to house those Docker hosts. Yeah, it's really just to be able to simulate multiple machines. It's very convenient. So if you want to simulate a multi-node cluster in the cloud, for example, you can use Docker machine to create yourself 1, 2, 3, 4 virtual machines in the cloud. Yeah. Sorry, is it? Um, virtual machines created the Docker machine. I mean, that will depend on where you're running. If it's your laptop, it's going to be RAM and disk and CPU. Same if it's running in the cloud. There's no fundamental limit with machine. So. Okay, I'd really like to. Actually, we've spent almost an hour already. I'd really like to get you the chance to do some hands-on. I don't know how limited people are in terms of having software, in terms of having decent internet connection. But please ask us if you want help. I'm frightened that people might be blocked. I mean, I can continue to do stuff just on the screen if you like. But I would prefer you to have hands-on, providing that's what you want. So please ask us for help, and we'll come round and help you, either using Play with Docker or using the tools that are on the USB keys. Okay, so maybe you have to do it platform by platform. Do you have Docker at all on your Mac? Okay, so you have what, Docker for Mac or Docker Toolbox? Or? It comes with, sorry, what installation? Okay, so you mean, okay, you haven't installed, you don't have Docker yet on your, installed on your Mac? Yeah. Okay, so yeah. So let me see. If you have nothing installed and you're on a Mac, then I suggest installing the docker.dmg image, which will be the Docker for Mac installation. There are a lot of options, unfortunately. That's why we tried to get people to install stuff in advance, but we know that, you know, it doesn't happen. Okay, that's weird. And you've all been signed up for a while to. Okay. 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 Sorry about that. I know I clicked all 60, and it went out. So, yeah. Okay. I received the email saying been sent. So okay. Sorry. Okay. So in what form do you have Docker? Is it? Yeah, but which is it? Docker for Windows? Is it Docker Toolbox? Do you know? Okay. Okay. Good. Then okay. So I think you'll just need Docker machine then to be able to create multiple machines. Which is maybe included. Do you want to see if it's on your path, Docker machine? Okay. Okay, it's going to be tough. I'm not sure how to get people moving quickly enough. Okay. Okay. Mm. Yeah. Okay. Um, how is internet connection for people? Because, okay. Okay, because that would have been a help. So we have a USB key for someone who wants to install.
Anybody else need one? I can make a copy.
Yeah, that'd be useful if you could make a copy, thanks. I was making copies this morning, but it was killing my machine. Yeah, okay. Um, it's better. Okay. So, okay, I'll go through on my copy of the notebook, and then at least people can see what the tutorial is about. And later, at least you can go through it. If people are able to now, so much the better, it'll be great. But at least you'll see what the tutorial is about. Okay, so far what have I done? I've created 3 virtual machines to create our cluster. I've initiated the swarm cluster with this Docker swarm in it. And I don't think I've joined any workers yet. Okay, so if I do this command docker node ls, we can see it's not very readable because I've made it much larger, but it's showing us that we have 1 node, so the master itself, in our cluster, that it's ready and that it is the active leader. Okay, and now I'd already pulled out this worker token value on the node, the worker node 1 now. I'm going to get that to join the cluster. Okay, so that's very simple, very quick. I'll now do the same with the second node. Okay, and now if I do a docker node ls again, we should see the 3 nodes that are part of our cluster. Okay, so we see our 2 worker nodes and then the master, which is marked as a leader. We could have had 2 more master nodes, in which case I guess they'd be shown as active, but only one of them would be the leader. Again, there's this notion of quorum between the masters. Okay, so now we have a 3-node swarm cluster. We haven't created any services on there yet, but let's use the command docker service ls just to see if there are any services running. So no. And now I'm going to create a service, docker service create. 1 replica means that we will have just 1 container running. Okay, so docker service create is like the equivalent of a docker run. You know, previously you do docker run to run 1 container on a particular node. Docker service create is saying, okay, create me a service across my cluster. This case I'm saying with just 1 container for the moment. And then it's up to Docker Swarm to actually decide on what node to place that 1 container. And then I will expose port 8080 just like we do with a normal container. And I specify this image, MJ Bright, that's me on Docker Hub, Docker demo. And I think I specify :20, so tag 20, version 20. Okay, so Docker service create, just one replica. I thought that would be quicker than that. It's actually the indication with Jupyter is when we have an asterisk here, it's that the cell is still running. Now we have a number, so it's actually completed. Yeah. Sorry, they match what? Oh, there's probably a lot of similarity. So things like -p to expose ports. There are probably a lot of common arguments, and probably some different ones as well. Yeah. Okay. Okay, so we launched that service, and then it did a Docker service ls again, just to show. I tried to do it fairly quickly. So we see the service now is running, and it's marked as 0 replicas of 1. So we asked for 1 replica, so 1 running container. And it isn't actually ready yet. That's still at 0, which is surprising. I hope it isn't downloading. So it should have had okay. Okay, yeah. Okay, this is why I said I have a script to load the images in, and I forgot to run that. So it's actually pulling that image from the network. Let me. Probably not going to be easy to interrupt that. Okay, so that took a long time. It had to pull the image. Luckily, it's a fairly small one. Let me just be here. I'm going to cheat and load the images, because if we depend on the network, we're never going to get anywhere. So that was just a 7 megabyte image, but it took probably a couple of minutes. So let me see. That here. Okay, it looks like I'm going to have a problem with my images, so never mind. Okay, so as I say, started that service. It's the version 20 of that Docker demo. And the tag is 20. Someone else wants the USB key? Anyone? Oh, okay. Okay, we see one replica running, and we can now do a Docker service PS on that Docker demo. Ah, interesting. So I'm making this smaller. I can read what was happening. It looks like I've been having a lot of network problems. Okay. So it looks like our service, we have a single container, and probably because we have networking problems, Swarm has actually been stopping and restarting that container on different nodes. So I didn't expect to see all these different lines. But okay, what can we see? I mean, I just launched one service with just one replica, so I expected to see just one line showing the service running. But in fact, there's four that have been shut down. The same service marked as reject. So I guess that's because of it's maybe just the time it took to load the image. I don't know. I've not seen that before. Okay. Well, I think that's okay anyway. It's getting some strange effects. So now I want to access our service. Okay. So if I do Docker machine IP S2P master 1, I get the IP address of our master. So I'm actually going to put that into a variable. And if I access that address in a browser on port 8080, I should see that that whale. Okay, so you see the image and from what container it was served up. And that image also has a different form. It detects if you make the request from wget or curl, then rather than providing an image which can't be displayed, will actually provide it in ASCII text. So that's the result. When I do the same request in wget, I can't see. I don't know if you can see very well, but it's a Docker whale. Okay, so that's our service running on just one node. Because when I started the service, I specified replicas equal to 1. So what we can do next is to scale the service up. So use Docker service scale, the name of the service equals, and so I'm going to put to 3. Unfortunately, the output now probably won't be so pretty because we had all those shutdown examples earlier. But we can see now that after doing the scale 3, we now have 3 running instances. So one on the node 2, one on the worker node 1, and one on the master. Yeah, that's right. So the master one was already in the current state of running. The 2 worker nodes, the desired state is running, and they're actually in the preparing state. And that probably means that it's going to be downloading the images again. So they're all running now. Okay. Okay, so if I redo, if I redo this request, we should see the same image, but we should see the container ID that changes on successive requests. So let me do that. Okay. It changed once. Okay, let me try from here. Up. I'll make this smaller. Okay, you can see bottom left in yellow, very bottom, the container ID is changing on successive requests between the addresses of the three containers, which are three separate nodes. Okay, so we've scaled successfully. Now what we'd like to do is a rolling update, rolling to the next version of our service. So we're on the version 20, and the version 21 will show us a red whale rather than a blue whale, just so we can see visually the difference. So I do first the service PS, just so we can see on the image name, we can see that all in this demo version 20. And now with a simple Docker service update, specifying a new image, which is so this Docker demo, but :21. We'll go to the new version. Unfortunately, this is probably going to take a while because it's going to download that image, and this image is, I think, 10 times larger than the other one. Go to a PS, what do we see? Okay. So for the moment, I see just the top line there. The worker node 2 is marked as version 21. All the others in that list are all the version 20. Hopefully if I redo that. Okay, so it looks like it's doing it serially. So it's pulling down the image to one of the nodes. Presumably when that has terminated, it will do the other two nodes. This will be slow. Okay, let me just move through the notebook, see if there's something useful we can do whilst that's going on. Okay, let me just talk about the next steps then, what we'll do. So as I mentioned, just draining a node. Imagine you're going to take a node out of your cluster for some sort of maintenance. You could just switch the node off and the swarm will adapt to that, but the proper way to do it is actually to drain the node, say, okay, swarm, move the containers off the node, and then we can take the node down. And so we'll be using this command. Let me just make that larger. Oops, lost it. Where was I? Okay. So Docker node update, setting availability to drain on one of the nodes. Okay, so telling Swarm, okay, just take all the containers off that node. And we'll see when we do that, because it's been told we need 3 replicas, it will stop a replica on node 1 and it will create an extra replica on one of the other 2 nodes. I'm not going to run that yet because I'm waiting for the rolling upgrade to work. Let me see where we're at. Okay, so the good news is our first node, in fact the worker node 2, is in version 21 and is actually running since a minute ago. And somewhere the master is preparing, so it's downloading the image. Okay, that one is running as well now. So we just need the third one. All right, okay, so the node 1 now is version 21, but it's preparing, so it's still downloading the image. So interesting to see okay, so it's shut down the old versions of these services as long as there's the version 21 on some nodes. Okay, still waiting for that last node. Ah, okay, it's there. So it's not very. Let me do a grep so we can see. If I grep on just the version 21, okay, we can see now that all 3 nodes are running the version 21. So if I go back and refresh this page, okay, so we've got the newer version of our service. Okay, so that was all very long because in this case we needed to download the images and our network is very slow. But the point is we did a single command Docker service update with the new image, and that was rolled out to all our nodes automatically. Actually, probably something would be good to add to that part of the tutorial is to show what happens if there's a problem with the service. So it's just as interesting. If that service fails to start, then you want to gracefully roll back to the previous version, or maybe manually you want to roll back. Anyway, our rolling update went well. And if I do a Docker service ls, okay, it shows there's 21, version 21, it shows we have 3 replicas running. We're in the desired state. And if I do my wget, so this time we'll get a red ASCII whale. Okay. Okay, so now I want to clean up, get rid of this service. Okay, so you see our 3 nodes. Our service is running across those 3 nodes. Okay, so I'm going to take out node 1. So I'm going to do updates, availability drain of node 1. And I do that service PS again. Okay. I'm going to do a grep so we can read this a bit more easier. Okay. So node 1, okay, everything is shut down now. So we still have a trace of them, but no containers are now running on that node 1, and we could actually take the node out. Equally important, of course, is what about the other nodes? So we should still have 3 replicas running. So we have 1 on node 2. We have 2 on node 2. Again, I'll do a grep just to make that easier to read. Or do a grep and running. That'll be easier. Okay. So we took our node 1 out. it created a new instance running on the node 2. So we still have 3 replicas, and that's our desired state. And it would have been the same. There we did the thing as a sort of planned maintenance of draining the node. But we could just have destroyed a node as well. Actually, why don't I do that? Despite all the initial problems, I'm feeling confident. Okay, so I do a Docker machine of, say, the node 2. Okay, so what do I expect to happen if I do that? We'll see 3 replicas now running on the master node. So if I do that, same Docker PS, thanks. Okay, so our node 2 has gone. If I do this again, okay. Okay, that'll teach me to experiment in front of you. I'm a bit surprised to see that node 2, it's marked desired state shut down, but the service is still actually running. So we actually have 5 instances for the moment where we should only have 3. Maybe it's just taking time to actually stop. Okay, well, it'll teach me to play. I'll come back and have a look at that later, see if it gets to the... I expect to only have 3 running instances. You know, this is the desired state. This is the actual current state. So we know we still want only 3 instances of our service, but we actually have 5. Okay, never mind. So we can see the value of the node drain then. Yeah, I don't know. I don't know if that's just going to take time or if it's a bug. It's surprising. Okay. What I'll do is I'm going to recreate that machine anyway. Okay, leave that going in the background. Another thing we can do is, if you know of Docker Compose, Docker Compose was providing a way of building up an application from a group of components. So Docker Compose, you have a YAML file which describes typically the containers to build, to deploy. Now the stack, the Docker stack, extends that. It's basically still a YAML file. It's very similar to Docker Compose, but it adds some other features, saying you can say that a particular container should be placed on certain nodes and not others. What I'm going to do is I should have the code already, so I don't have to touch the network. Let me just check. Let me okay. Might be better if I do that from command line. Okay, so I'm looking at that YAML file. I've chosen here an an application done by Alex Ellis, a Docker captain in the UK, called Function as a Service. So the idea is to implement something which is called serverless computing. The idea of serverless computing is instead of creating an application that you then run in a virtual machine or in a container where you're deploying a whole application, you implement maybe just a function, and it will be doing something like waiting for a notification, like a GitHub webhook, for example, some other external notification, and then it will take some action based on that. Maybe return a result, maybe invoke some other service. But the point is that to run that service, you don't have to have a container spawned for each request or a container dedicated to each request. It's really just a function that you invoke. And that's, in fact, you maybe have heard of things like AWS Lambda, which is one of the first deployed solutions of that. Or there's also Google Cloud Functions, Azure Functions maybe as well. And there's an open source project called OpenWhisk from IBM. It's not important. That's just Alex Ellis has done an implementation of function as a service. So I'll show you that. Basically, we have a compose file that shows the different components of this function of a service application. There's a gateway. There's Prometheus, which is a monitoring application. So not strictly necessary for function as a service, but it's part of this solution. Webhook Stash, which presumably is going to be listening for requests coming into our function as a service. Stats package. Okay, so basically, I mean, it's a set of services that we're defining in YAML. What we can see is we define things like networks. Okay, so we have a network called functions, which will be across the containers for this solution. Okay. But I really want to use this just an example of how to deploy a stack. So I'm going to run this function, Docker stack deploy, and we'll call that stack func, and we'll use that Docker compose file I just showed you. So it's Docker stack deploy is reading that YAML file, and it's creating the services that were listed in that YAML file. Should be fairly fast, actually. So again, it's interesting to see that again, Docker provide a simple tool to allow you to build up quite a complex application. With the deploy stack, you can specify parameters in that YAML file, saying that a particular service, well, how it might be distributed across nodes, whether you want it placed on particular nodes. So you could have labels on nodes. Maybe it's an application that's going to make use of some GPU capability, or that is quite disk intensive. And so you want to place services relative to the hardware capabilities of nodes. You can also specify some replication. Yeah, I forgot to stop my my service. So there's some extra capabilities within the YAML file that are used by the deploy stack. So that would have deployed everything, except I forgot that I've still got my Docker demo running, and there's a clash on the port. Let me see. Okay. Let me just stop my demo service. Okay, so my Docker demo is gone. Good. So I'm going to rerun that deploy stack, which hopefully will be much faster this time. In parallel, so this was very quick when I did it earlier, but okay, so it's completed. I'm doing two things in parallel. One is I've just opened an SSH tunnel into my Docker machine so that I can get to that port, which I think is 8080. And I've exposed it locally as 9090. Looks good, but very slow. Okay, so that is my function as a service. Okay, it doesn't really matter what the function as a service is about. The point is that with just one single command, which actually normally runs much quicker than that, we're deploying a whole stack of containers. Just to show you what it's about, function as a service. I mean, these are just silly functions, they just to demonstrate. So one is echo it. So I type in hello world here as a text body and invoke the function, then it returns to us hello world. If I do word count function and invoke that, it's telling us that we have 0 lines, 2 words and 11 characters. It's basically doing a WC. The point here is, in terms of serverless, what that means is we have a set of functions available to us. We can actually create our own functions which don't require creating a new machine to house that application. And then they are available as a web service. That's what serverless is all about. But that wasn't the subject here. It was really just showing an example of deploying a whole application stack very simply. In the background, I started to download an application called the Visualizer. I expect I will have to just cancel it because of the networking. Yeah, over here, we're never going to get there. It's downloaded 10% of one of the image layers, so I'll just stop that. Thankfully, I put an image earlier just to show us what that's about. So when you have a Docker swarm, there is an existing application. So this is the name here, Docker samples / visualizer. And this will allow you to see the containers running within your cluster. So in fact, this morning I created this image. I'd done this same deploy stack of the function as a service application. And this is how the different containers were assigned to the 3 nodes of my swarm cluster. Curiously, there's nothing on node 1. Okay. Because I'd done the drain step before, and I didn't take node 1 out of the drain state. So that's quite interesting to see. So this visualizer shows us how our containers are assigned to the different nodes, and it works in real time as containers are moved around. So I would have liked to have shown you that actually running, but it's, I don't know, maybe a gigabyte image or something like that, and we're not going to get there. Okay, so I've taken much longer than I should have done. I've taken up half the time just showing Docker Swarm on the command line. What I propose is then to look at the Python equivalents for Docker Swarm, if that's okay with you. The alternative would be to look at Kubernetes or Mesos. Is anyone able to actually follow along, actually? Yep, okay. Yeah. Sorry? Yeah. Okay. So say, I mean, all these materials are in GitHub. They're on a branch for the moment, but I'll try and do it this week of just finalizing that and putting it on the master branch. It'll be easier to get to. Okay, so if I go into the Docker Python stuff. Clear the outputs for everything. Okay, so if I look, I should still be with 4 machines. So 1 out on Azure, which has nothing to do with this, and then the 3 Swarm cluster nodes. So I'm just going to reuse those. In the notebook, I do actually describe, I show creation and deletion of Docker machines from Python, okay? But I don't really want to waste time on that now. But I'll just show you what it looks like. So basically there's a Python module called machine. It works like this. You create sort of a machine, a link to the machine by pointing to its executable. Okay, and it's a very simple wrapper around the binary. Okay, there doesn't seem to be any real advantage compared to the Docker machine executable, but just if you want to do things from Python, and it probably has more limited capabilities. I'm trying to think of an example. Yeah. It will be a separate process, yeah. So we can use this Python machine module. The notebook is there on the web, so you can see how that's done. But I'm going to skip that part of the notebook. Let me see. So, So I'm going to just select some cells. I'm going to load this pprint module to be able to pretty print some of the stuff, because we get a lot of JSON back with the Python binding. I put some checks in for the module. I'm actually running Anaconda Python distribution, Anaconda 3, and that's actually the version is 4.3.1, I think, but it's the Python 3 version of Anaconda, I mean, the latest version. The modules that I'm using, Docker Machine, Docker, and also the Kubernetes API aren't available in the Conda repository, so I'm actually pip installing them. And I do some checks here, check the versions of the Docker modules. I actually do a very simple check of the first one, the Docker version. I see just today there was 2.3 that came out. But the point here was just to check that we're at least version 2, because the Docker API, or the Docker Python module changed quite significantly. And so you really need this version 2 to be able to use this lab. Okay, so I have a check, just that we're okay in the Docker version. Okay, I have an initial section. Oh yeah, that was for. Yeah, I'm going to skip that part. That's just using Docker Machine, so I'm going to skip this Docker wrapper. Okay, that's creating nodes to the Swarm cluster, so we're not going to do that. Okay. Actually, what I will do is I will use the machine module just to pick up config parameters. Okay, so I'm going to run this cell. So I now have this object that represents Docker Machine. And from then in, so I'm not going to create any machines, but I will use that machine module just to pick up the configuration. So now if I want to pick up configuration of my master, I do this m.config. Okay, and so it pulls back the URL of my master and the TLS certificate information. And just for completeness, then we can pull that in form of environment variables. Okay, so I'm going to use that to create a Docker client. So I'm saying Docker client is part of this Python Docker module. Okay, so I'm going to recuperate the config using my Docker machine module, and I'm going to create a client pointing to my master. So it's this line SW master1 equals Docker client with that config. Sorry. Yeah, okay. Whoops, where are we? Okay, so I'm picking up this dictionary m.config, and I'm passing that into the Docker client to create my client. Okay, and I've done the same for the worker node 1 and the worker node 2. And I built up a dictionary just of those three client objects. Okay. So first thing we can do is there's a ping method allows us to check connectivity to those three nodes. So they're all pingable. Good. We can look at images that are on the nodes, or I'm checking just on the master. So you can see we've quite a few images present. I was surprised here, I don't know why it's giving some empty image names. I hadn't seen that before today when I started running this deploy stack. Let me see, swarm init. Okay, the way this notebook was done, I was intending to recreate all the nodes, and so we do the swarm init. In this case, okay, so if I show the networks now, we'll get more than just these three networks because we already have our swarm initialized from the command line stuff I did. So I'm not going to run that, but just show that we can do that. In fact, it's on our client, it's client networks.list that we use to recuperate the list of clients. By the way, I don't know if you're aware of the changes in the Docker command line client in the 17.03 release of March. They're moving to some new form of commands where they tend to be Docker object verb, so Docker container ls, Docker image ls, and this sort of thing. And we can see that corresponds more to the way the API works. So like we have a client networks list, it's like the command line, which is now a Docker network ls. Okay. So I'm actually going to list those networks because we have more than we might expect because we've already done the initialization of the swarm. I'm going to pick up the IP address of our swarm master. Okay, so there's this function m.ip, so it's just like I did earlier, Docker machine IP swarm master on the command line. This time I'm doing it in Python. Okay, I can do an info on that swarm master. It's going to be quite verbose, like we had in the command line. There's a lot of information there. Normally at this point we wouldn't already have swarm created. So here we're now dealing with JSON objects, so it's actually a dictionary that's returned, and we can look specifically at the swarm part. And we can pick out specifically this thing, local node state, which is really asking about the swarm state. So it's actually already active because this is still the swarm cluster we initialized earlier. By the way, I would have cleaned up. I didn't want to recreate the machines because it's taking us a long time. I should be able to leave the swarm so that I can then show you the steps of joining. But I've actually had problems with leaving Docker Swarm. It seems to be a bit buggy at the moment. So that's why we didn't return to a clean state. Okay, so if we look at okay. Okay. Okay, so if I look at the local node state, it's active. Okay, normally we would do a Docker swarm init on command line, and there's the same here. We take our swarm master client, .swarm, .init, and so we can create a swarm cluster in that way. Obviously, that's going to produce an error if I do that because we've already initialized our cluster. Okay, we've already seen the info. Now this, oh okay, it is instantiated, okay. So we can, I will show all that just so we can see. Because the next step, I pull out the swarm section of that info and I pull out the nodes element. Where are we? Swarm, swarm, swarm. Hold on, let me do it again. So I'll pull out just, oh, made a typo, so I do it wrong. Okay. Okay, so if I just pull out the cluster part, and we can see there's an element nodes telling us the number of nodes in our cluster. So it's our single master and our tool workers. Okay, we've already seen the local node state is active, of course. I don't remember what the attributes tells us. Okay, tells us when our swarm cluster was created. Some of that information. Again, we can obtain the join tokens. So I mentioned earlier that we can get a master token, or manager token, or a worker token. We'd initially created a master and then we joined the two worker nodes using the work token. But alternatively, we could have had some other nodes that we wanted to join as masters using this manager token. And so the show networks I didn't do earlier. Oh. Okay. So I actually had a function to show the networks, which now isn't defined because I didn't run that cell. Hold on. Me. Okay. Okay, so that show networks function, which is just looping around the client networks list. And now, okay, if I run that, we will see those networks. So just as we saw in command line, the list of networks after creating the swarm cluster. Okay, so I'm not going to add any master nodes because we don't have any other more nodes. Okay, similarly, it's interesting. So I wrote a function just to show the state of the nodes. So equivalent of a Docker node ls, which is looping around a client.nodes.list and just pulling out some status information. So it's interesting to see, maybe you can't, let me make it larger. Where are we? Okay. So we can see from the previous section that our node 1, worker node 1, is still in the drain state. I drained it earlier. So we're just stepping through, seeing how the API really obviously provides the same functionalities that we see in the command line client, and then the Python bindings provide the same sort of client object and then verb type of interrogations on the API. So let me see. So there, okay, we have the swarm joins, which obviously aren't going to work because our nodes are already part of our cluster. But you can see it's the same basic form. We're using the Docker client, so we have a specific one for the worker node 1 and worker node 2. So SW node 1 .swarm.join with the appropriate parameters similar to the command line version. Okay. So normally I would add those one by one. I would show the number of nodes increasing, but of course we already had our cluster, so as we've already seen that. I did try leaving the cluster, as I mentioned earlier, but it seems there's a bug that the cluster seems to break when we do that, so I won't do that step. Okay, so if we want to start a service, again, look first, see what service is actually running on our node. We have quite a few because of the function as a service stack that I deployed earlier from the command line. Let me see. So to create a service, it's more involved than doing it from the command line. We have some structures to fill out. So first of all, we fill out a container spec, giving the name of the image that we want to run and the parameters for the default command we want to run. So in this case, I've specified an Alpine image, and I wanted to do just an echo hello by default. We provide some endpoint spec, which is basically saying how we will expose ports from the service. So you can see in this comment the way we can specify the external and internal port, and in particular the protocol if we want. By default it's TCP, but we can say explicitly that it's UDP. In our case, we'll do just a simple 8080 to 8080. I think I'm going to change that because I'm not sure we have 8080 still available. So let's make it 4040. Okay. And from there, I'll call this function services create. I can assign labels to our service. I specified the image, and I'm actually going to overwrite the default command. So I'm going to say, okay, this service is something that will just do a sleep 60. Actually, I'm going to make that smaller so we get through quicker. Okay, so now I'll actually launch the service. It's taking a while, don't know why. Ah, of course. Yep, network, because we haven't used the Alpine image yet. Actually, that went strangely fast. So if I do a services list, let me just see. Okay. Would have been better if I'd pretty printed that actually. It's not so readable. Let me. Okay, let me explain what I'm trying to do here. So I've launched an Alpine image as a service with a rather strange command, which is just sleep 30 seconds, just to really show that what happens if the container we're running exits, okay? Because this isn't just a Docker run anymore. We're really saying this is a service, something that should persist. Unfortunately, because the old service is running, it's not very clear what's new or old here. Let me see what this gives. Okay, so that first service in the list, 2MD, okay, so that is new, okay? And what I am trying to show is that after sleeping 40 seconds, we still have that service running. Even so, though we just specified a thing with sleep 30, we might imagine the container has exited and then the service isn't there anymore. No, a service is something that persists. And so Docker Swarm will recreate a container to keep that service running. Okay, so this is actually written assuming there was a single service. Let me just check that it is the right one that we're going to see. Okay, so it is that first service in the list, which is an ID of starts with 2MD. So if I run this cell by chance, thankfully it's the first that comes out in the list, so we can see they're looking at the right object. Let me just make this more readable. Okay. Okay, so we look at the attributes of that service using service.attributes. Okay, so I'd from my services list, I'd simply just taken the first element. Simply, I knew it was the right one. Otherwise, I would have to search through and check that it was the right name. And then for that service, then I'm listing the tasks associated with it. And if I scroll down here, okay, so we see a first task that's been shut down that had a sleep 30 command. We see a second one, sleep 30, a third one, fourth one. So basically, our service is running this container. Obviously, after 30 seconds, it exits. Because it's a service, it's relaunching that each time. And if I do a, okay, containers list isn't so useful. It is because I've left the functions as service running that we have a lot of stuff running. Okay, I can remove that service. Service object I'd selected from the services list, and I can now do a remove. And well, we still have a lot of containers, a lot of services running because of the function of a service I set up earlier. The other thing I wanted to do was then just doing the same thing, but for this Docker demo image. So I set up the Docker demo version 20. Okay, actually this isn't going to work because I still have the service running. I would actually have to clean out. Okay, let me delete the existing. Oh no, it isn't running. Okay, no, okay. I forgot my other notebook in the command line. I did do the cleanup actually before we did the drain node, so we're okay. So this is just the Python equivalent of doing that service create. So again, we specify the image that we want to run. We have a default command associated with it, which we're not actually going to use. And then when we create the service, so we're given endpoint spec again, 8080 mapping onto 8080. Again, I'm going to change that because I'm not sure we have that port available, so 3030. And we are going to launch that. Okay. I'm not going to do the services list because that's not so useful. Okay. So I wrote a show services just to loop around the master node. Okay, that's a bit more useful. And we can see that the Docker demo service now has been created, which it didn't have before. Okay. Or the equivalent from the command line. Oh, okay, I know why that's. Okay. Okay, and similarly, service.tasks, we can have a list of all the tasks that are running as part of our service. Okay. Okay, we can look at all the, so using containers.list on each of the clients we have, so we can see the actual containers by node. Okay, in fact, everything is running on master 1. And that's normal because we've done the drain on node 1, and I deleted and recreated node 2. And that was after we'd actually deployed the function as a service. Okay. And if, again, we redeployed the Docker demo, and we should be able to access it online. Now I exposed is 3030 this time. And there we get our blue whale not very visible at that size, but where are we? Okay. So I've not gone very far with the Python module, but we can see how we can access all the same objects, containers using container.list, networks.list, service.list, and so on. What I can't do with the API is do a deploy stack. That's not available at that level of the service. That requires more logic above that. Okay, that's all I'm going to show for the Docker Swarm Python. So just to say, these are written assuming that we're running locally, or assuming we're running via Docker machine. But in principle, all these things, the command line and the Python version, could be run on Play with Docker. I'm just wondering, do we... Okay. See how the network's performing now. Can I access Play with Docker? Do people know Play with Docker? Okay. Let me see. I would like to show images of the bus. Oh, yeah. Oh, maybe that was a bus then. Oh, no, there's a bus. Okay, looks like the network is behaving a bit better. So if you go to play-with-docker.com, you get to this site. You have to get past the initial capture test. And then this website is basically allowing you to create nodes running Docker. So if I do here, add new instance, it's going to create a new machine. It's actually running Docker in Docker, but that's a detail you don't have to know about. It's as if I'd done a Docker machine create here. So the advantage of this is that you can be running this purely in the web. You don't have to install anything. Okay, so I don't want to spend time on Play with the Docker, but just so you know, you can use this. A session here lasts up to 4 hours. You can see the countdown timer, top left there. I can click on Add New Instance. I can create up to, I think, 5 instances. And it's possible to do a swarm init and actually create a swarm cluster purely within this web interface. And then there are indications of whether they're master or worker nodes. It's a really nice environment. I recommend giving it a try. And there are now a set of labs that can be run directly. Okay, so that's labs.playwithdocker.com. No, it's not what I was expecting. Okay, never mind. It must be a different... it's training. Okay, sorry. Training.playwithdocker. Okay, so if you go to training.playwithdocker.com, you have this page where you can actually select a tutorial like Swarm Stack Introduction, and it will launch a Play with Docker environment. So again, you can experiment with Docker online without having to install anything on your system. So if I do, for example, a Docker version here, we can see it's running a very recent version of Docker 17.05. Okay, release candidate, but that's pretty good. Okay, so I just wanted to point that out. I mean, you would have been able to follow along with that if the network had been working a bit better earlier. But you'll be able to do that from home. Okay, so we've looked at Swarm, both command line and Python. So if we look at Kubernetes, see, we have 1 hour left, so I'm just wondering how to best use the time. Do you have questions on what I've done so far? Yeah, sure. So I would tend to show Kubernetes now. We can look at Kubernetes on command line, Kubernetes with Python, or the Mesos stuff. I propose Kubernetes command line if that's okay with you. Okay. I could try and do that fairly quickly and then show a bit of the Python as well. Okay. So Kubernetes, of course, is something that came from Google initially. Google have been a large consumer of containers before Docker existed as a company. And they launch, I don't know, billions of containers per year. I believe that every Google search actually launches a container. That's pretty large. So they had some internal projects that were doing container management. Notably, there's Omega and the Borg, and they decided to open source something based on that software. And so that was Kubernetes, and it was October 2014. So it's still a fairly young project, Kubernetes. And they donated that to the Cloud Native Computing Foundation, CNCF, and so they manage Kubernetes development now. And there's a very large ecosystem around Kubernetes. And there are several commercial offerings from CoreOS with Tectonic. Canonical have one as well, and Red Hat produce the OpenShift platform. Okay, so again, it still adheres to this basic model of having a set of master nodes in a quorum with some sort of leader and a set of worker nodes. A slight difference to other models is that we deal with the notion of a pod rather than a container. So at the lowest level, you create a pod. What is a pod? A pod is basically one or more containers that are all within the same namespace. They actually have the same IP address. So it's as if they were a machine. Okay, still a set of containers, isolated. That it isn't a virtual machine, but they share the same IP address. Okay, and that can have some advantages when you want to be able to co-locate containers, and maybe if they're containers that you want to scale together. So that's the basic level of execution, I'd say, within Kubernetes, the pod. And there are many other concepts like services, I've seen already in Docker Swarm. There's a concept of replication, and so we have actual objects, replication controllers, and a newer object called replica set. The advantage of replica set, so it, obviously replicates instances of your service. Replica set allows as well, it automates the rolling upgrades. Kubernetes also makes heavy use of labels. I mentioned a little bit when we're launching services in Docker Swarm, we can assign labels. Kubernetes also uses labels and selectors. You can select maybe a group of services or pods or whatever based on the labels that are assigned to them. And that can be very useful for being able to maybe just query parts of your cluster, which could be enormous, maybe apply particular updates just to particular objects and not others. So in Kubernetes, everything is based around the API. There are basically 3 ways to control your Kubernetes cluster, either through the GUI dashboard which exists, directly through the API, or through the kubectl command line client. The worker nodes basically have a process called kubelet, which is first point of contact of the worker node for all communication between the master and the workers. It has a container engine which will launch the containers running in the different pods. There's some capabilities like kube proxy, which can facilitate connecting through into services. DNS add-on to be able to address services by their name. Okay, so rather than connecting to service based just on its IP address, you can connect to it based on the service name. And as I mentioned, pods, so it's one or more containers and they're all sharing the same IP address. So obviously you have to make sure that there isn't a conflict in ports that are exposed by those containers. Okay, that's a list of several of the concepts. So I've mentioned already, obviously, pods, replication controller, replica set, deployment. So it's the way we manage replica sets, and it provides the capability to do rolling upgrades of a service. Services, just like with Docker Swarm, it's something that gives you an addressable IP to address a service, which then might be actually implemented in pods across various nodes. Labels, and then selectors to be able to filter based on labels. There's the notion of secrets, which exists also, by the way, in Docker Swarm. Daemon sets. Daemon sets allow you to specify a pod that will run on a subset of nodes. The idea is you specify a daemon set and you're saying this is something that I want to run just one of on maybe all my nodes or maybe just a selection of them. But it could be something that you want to always have running, like a dashboard or something. There's also the notion of jobs, so short-lived pods. So like it's like launching a pod that performs a task and then goes away, just like running a container, rather than creating a service, which is something that persists in time. Okay, so for the tutorial, I propose to use Minikube. So Minikube is a fairly nice encapsulation. In fact, there are several ways that you can run Kubernetes. Kubernetes already is available in Google Cloud Engine, in Microsoft Azure. But if you want to run it locally, then I'd say Minikube is a particularly nice way to do it. So Minikube is fairly large. It's about 80 megabyte executable. which then downloads an ISO file about that size that encompasses a whole Kubernetes cluster in one node. Okay, so okay. So today, Kubernetes uses Docker. Going forward, there is a project called CRIO to have a native implementation of containers within Kubernetes. I think you can already use Rocket from CoreOS with Kubernetes, and I think there's probably at least an alpha or beta of CRIO as well. But Docker is probably the most stable, what's easier to use today. Okay, so I'm running version 0.18 of Minikube. I'm actually surprised because I have 0.19, but anyway, I'm going to run with that. And I also have this command line client kubectl, so the equivalent of the Docker client, if you like, for connecting to a Kubernetes cluster. If I do kubectl version, it's showing us, it's not that readable, but it's showing us version 1.6.0. So it's telling us that we're running Kubernetes 1.6.0. Or rather, this client is from Kubernetes 1.6.0. So my cluster isn't running yet, normally. Good. Where are we? Okay, so I'm going to start that. Actually, I should have cleared all these outputs before. Let's just do that. All right. Okay, so I'm going to do a Minikube start. That doesn't look good. What's up? Let me do that from the command line then. So let me just. Okay. I don't know if this is the problem. I can see VirtualBox has a virtual machine in a strange state. Let me delete that and see if. Okay. This is the first time I ever see this error message. I don't know. Okay. Might be because I've been running a newer version. Let me. Okay, that was the problem. I don't know why I'm in version 0.18. I've been using 0.19, but I just want to run with what I have. Okay, so it's actually the network is running relatively well now, because that's downloading this 90 megabytes ISO, and it's working. Okay, so basically I've done just a Minikube start. It's downloading this ISO, and I think it's fairly fast to actually launch the Kubernetes cluster. So what it will do is it will launch one VirtualBox virtual machine with this ISO, and that will be our Kubernetes cluster. So unlike with Docker Machine earlier, we had 3 nodes for our cluster. This time we will only have 1 node, but we will still see the principles of working with Kubernetes. For info, okay, we're not going to have time to look at the Apache Mesos parts. I hope that's okay. I know from the survey people weren't so interested by Mesos. We wanted to show it, but you might be interested to have a look. So there is a tool called Mini Mesos, which is interesting. And it's well worth a look. Mini Mesos is produced by Container Solutions, who do consulting around containers. And they've also put some tutorials online, which are well worth a look. And I insist that these 3 container orchestration engines all have value, as well as other alternatives. Docker Swarm really has the advantage of ease of use. Kubernetes is really quite extensive and has a large ecosystem. And Apache Mesos, I would say, is the one that has really been proved most at scale. Because even though Google has this vast experience of containers working at scale, that's not with Kubernetes. That will come, but Kubernetes itself is still a young implementation of that. Whereas Apache Mesos can work with tasks other than just containers, and it has been used to scale up to 10,000 nodes. Okay. So I just wanted, as we're waiting, just wanted to insist on the value of the 3 orchestration engines. I will finalize some of this stuff and make sure it's online. So please take a look, and you'll be able to either do the things that I've been doing here, or things like the Mesos, which I won't have had time to do. Okay, this is slower than I thought. And what status tells us. Running. Okay, it's good. Okay, it's done. Okay, and so in the same way that with Docker Machine, we can do Docker Machine env and the name of one of our machines. Here with Minikube, there's a Docker env argument we can use to pick up the environment variables, so we can access the Docker daemon running within the Minikube environment. So just for information, as I mentioned, Minikube is actually using VirtualBox under the hood. So I do a VirtualBox manage of running VMs. We'll see our 3 swarm nodes, and then we have this Minikube virtual machine running as well now. Don't be misled that we have the swarm nodes running. We don't need those, of course. It's just that I haven't cleaned up. So if I do eval of that Docker env, now if I do Docker PS, then we'll be accessing the containers running within our Minikube VM. Okay, I know what that is. It's it's because I'm running an old. Okay. I'm running an old environment with a newer Docker, so I have to run this. I have to source a file to be able to access my Docker. I don't know why I'm getting an error that on that Docker PS. That's strange. Just do those things again. Oh, okay. Okay, there's an error message, but I don't know. Okay. Let me just show you first. Okay, so with Minikube, just like with the Docker machine, we can SSH into one of our machines. So Minikube has the SSH as well. So I can do uptime or something on our node. I'm going to go in and just... Okay, so within the VM I can run Docker. It's just my local... This is the demo effect. I'm not sure why I can't. I suspect it's the version of Docker. Okay, no, it's just slow. Let me try it again from the notebook. Okay, I don't know why my Docker client can't connect to the Minikube from within the notebook. I'll do stuff from the command line if I need to. Okay. Okay, so kubectl comes separately from Minikube, which is a small executable to be able to access the APIs. So if I do kubectl get nodes already, it will tell us what are the nodes within our Kubernetes cluster. With Minikube, we only have one node. Okay, so it's telling us our Minikube node is ready. It's existed for 5 minutes, and we're at version 1.6.0 of Kubernetes, which is pretty well the latest version. I think it's been out for a month or so. If I do kubectl get pods, we'll see there are no pods running. Actually, there are pods in another namespace. There are pods for Kubernetes itself. I forget, there's an option, all namespaces or something to see them. Let me try that. This may not work, but... okay. Okay, so we can see there's a separate namespace called kubesystem, and these are internal pods that are working as part of the Kubernetes cluster. But if I do get pods, it shows nothing, so I have nothing running in our default namespace. Okay. Similarly, service, we should have no services running. Okay, Kubernetes itself. But we should have no deployments running. Okay, so I'm in there. Yeah, kubectl command line client tends to work in terms of generally kubectl verb object. It's like we have get nodes, which you've already seen. We can there's also describe nodes, which shows much more information about a node. So basically, yeah, we have information about the node, any labels that are associated with the object, in this case a node, and generally a history of events associated with the object. Okay, we can see that this node, it has 2 CPUs. I guess that's about 2 gigabytes. Yeah, 2 gigabytes of RAM. And it has a maximum capacity of 110 pods. Okay, and we can see within that namespace some of the kube system pods that are running. So things like the kube DNS add-on that I mentioned earlier, and also there's a Kubernetes dashboard. So the dashboard, we could look at that. I don't remember if we see that here. Yeah, we do. Okay. Let me do this differently. Okay. Okay. So Minikube dashboard will actually open the dashboard in the browser. I always prefer with the -URL option. So it will just print the URL. Okay, and this will show us the actual Kubernetes dashboard. So another way of accessing to the system. If I look at namespaces, okay, we see this kube system and kube public. But when we did get pods alone, there were no pods because that was in the default namespace here. Okay. So that's quite a nice GUI we can maybe come back to. Okay. So to deploy an app in the most basic way, we do a kubectl run. So let's do that. So I've done run my nginx. I guess this is going to take some time to deploy. So I do a get pods now. Okay, we see, sorry, that was with the replicas equals 2 option, okay? And so we see that it actually has created 2 pods. Okay, they're in the container creating state. That means that it actually, but the major thing that takes time, of course, again, is downloading images. Okay, and that's ready. That's on port 80. Let me. Okay, sorry. So kubectl, I should be able to see the cluster information. Okay. Yeah, I don't remember how to get the address to the service. Let's skip over that for the moment. What I wanted to show you actually was, so I did get pods. Okay. In fact, the run command created a deployment object. So if I do get deploy, we can see there this my Nginx deployment, and that had 2 instances, so these 2 pods that were generated. What I wanted to show you is that, in fact, typically we would do that, creating it not from the command line like that, but from some YAML file. So like Docker has Docker Compose or YAML files. Similarly, we can have the same thing with kubectl. So I can do a kubectl get -- export. Actually, I've never run this command because I entered it earlier. I didn't have Minikube running, so I hope the syntax is good. No, it doesn't. Okay, second shot maybe is good. But no, up. Okay. Let's try again. What is the syntax? Okay. Okay, sorry. It was literally just before the session I added that. I need to look up the syntax to get that right. But you can export the YAML representing an object, and it's normally that YAML that you would then use to create a deployment or create a service. And so normally, okay, so what I had done was a kubectl run, okay? And if I had been able to create my YAML file, in fact, this is how you would generally do a deployment from the command line. Obviously, there are API equivalents. So kubectl create, and then specifying the YAML file as input. Okay. Let's see. So I've gone through this very slowly. So of course our pods are all in the running state. I can do a describe of our deployment, and we can see here it's marked. Okay, in the replicas line, we can see it's marked to desired. So again, just like the Docker Swarm, these orchestration engines, we're telling them this is our desired state with this many replicas. And then it's telling us the actual state. So 2 available and 0 unavailable. It's a rather long-winded saying that, it's the 2/2 of Docker Swarm. So we're in the desired state, which is good. We have 2 pods running. So to access that, there are different ways of accessing the service. In fact, I tried earlier, but of course it wasn't right. I said accessing the service. We don't have a service yet. That's the point. We have a deployment. There are basically 2 ways of accessing that. Well, there are more. One is to use proxy service. We saw the Kubernetes proxy in the architecture of the worker node earlier, and we can set that up via kubectl. Let me. I don't remember if that's the syntax. No, it isn't. Okay. Port, yes. Okay. So now this means that on my PC, port 8080 is being proxied through to our Minikube instance, and I should be able to get through to that port. In my cluster. Okay, so let me see. Okay, so I'm getting through to the actual API here. Okay, I can access that through the kube proxy. Okay, and we can see that if I loop through, hold on, is that right? Yes, it is. No, it isn't. Okay. Change that port number to 8080. If I loop through the names of the pods that I have, I can actually interrogate the API. Okay, and now this is being routed through to my actual container, the Nginx container. Okay. So that was one way of doing it, through a proxy. Let me just kill that, okay? So if I redo that command, we won't see the HTML coming back. We'll get a connection refused, okay? The better way to do things is to actually create a service or to expose our deployment. Okay, so I use this kubectl expose deployment of our deployment, and I specify type equals node port. And what that means is it's saying expose this deployment on each node, expose this port on each node. Okay, so it's been exposed. If I do get pods, it's still running, get deploy, and describe deploy. Okay, now we can obtain the URL of our service, so we can actually access it. Okay, so we should be able to access it now using that. So I can click on the link here and go to it directly in the browser. Okay, so it's this using Minikube saying, okay, give me the URL of this service. Now, a moment ago, we couldn't connect to that because we hadn't yet exposed the port. Okay, so it was this command, kubectl expose deployment type node port, which has made that service now available. Okay, or from the command line, of course, through curl. Okay. We've 20 minutes to go. Do you prefer that I keep stepping through the command line, or I can go to the Python version, if you like? Yep. Okay. We have one vote, so that's good. Yeah, sorry, I really had hoped to just show you things and then have you step through, but okay, it wasn't to be. Okay, let me... I'm going to run that kube proxy again. So in fact, I haven't gone very far with the Kubernetes Python stuff yet. What I have is more just like examining what is in the cluster and doing some cleanup. But that is still already useful. Look at the APIs. Just define that. So here, I wrote a function called showPods by namespace, which shows us already, the basic things to do. So what I do, I've done a pip install of the Kubernetes client, and this is the version 2.0 of the client, which is, I think it's only been out for a week or so. We perform this config load kube config, okay, which is going to allow us to access the APIs, and then we create a particular API client, and we have to choose the particular API that we want to use, and we'll see in the examples that we'll mix and match clients because there are several different versions of the API available that they're complementary. You know, there's no conflict. It's just that there are, you know, beta APIs that are providing new functionalities. Okay, so here I've just taken the core version 1 API, and I'm using that to so v1.list node. Okay, recuperate the list of nodes in our cluster. Again, this is going to be just one node, Minikube. Similarly, we can loop around the namespaces that are available. And within that, then I just show the pods running in a namespace. So let's run that method. Okay, actually, hold on. I'd forgotten to clear the output of the... Let me clear them anyway. Where was I? Okay, I'll run that again so you can actually see it being generated. Okay, so cluster nodes, yeah, no surprise, just this one node, Minikube. List of the 3 namespaces that we saw in the dashboard, default, kube public, and kube system. And then we can see the pods running in those namespaces. So in particular, our 2 MyNginx pods running in the default namespace. Okay. Okay. I'm going to skip those examples. Okay. Okay, so I had yeah, we haven't got very far in the command line stuff. There isn't a lot to clean up, but nevertheless, just showing how I implemented a function to do cleanup. And it's interesting to see already that I'm pulling in another API. So this, if you see here, this apps version 1 beta 1 API. And that is because so we've already accessed nodes, namespaces, and pods. And the beta API and extensions, I needed those to, to do deletion of namespaces. Deletion, replication controllers on version 1. Okay, deletion of replica sets, which are a relatively new feature. Okay, so just showing that we can mix and match the different APIs at the same time. So this this method, cleaning up pods for a particular context. So I'm using the default context. So I didn't explain the context is kubectl context, so you can manage different clusters with your kubectl, and our default one is just the Minikube cluster that we've created. Okay, so I do a config, I do a load kube config as earlier, which allows me then to create a core version 1 API client. And I'm doing, again, I'm doing a beta client as well, and a beta extensions client. That's the way these things are done. So I'm looping through the namespaces. I'm just checking if the namespace starts with kube, then I don't do anything. I'm not going to delete actual Kubernetes system itself. If it's anything else, in fact, our default namespace, I'm going to loop through looking for deployments first of all. Okay, so there's this list namespace D deployment that I call with the name of our namespace. There are different functions for listing deployments, but I wanted the one that lists them by deployment because I only want to touch my default namespace. Okay, and then that's using the Beta API, and I use delete namespace deployment for each of those deployments. Okay, similarly for replication controllers, and that's using just the version 1 API. Same for replica sets, using Beta extension API, and then pods on the version 1 API. And I'm doing those in a particular order. Okay, so if I... Interesting. Oh, okay. 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 Excuse me, just because I'm selecting cells, I'd forgotten to import the pprint. Oh, okay, there must be some other things I've skipped in this notebook. Okay. Yeah, I think it's picking it up from .kubectl. Let me just check. Okay, so in my home environment, .kube, in fact. Okay, so by default, it reads the file. Oops. .kube/config. And I guess in there, okay, we can see the server URL there. And that's what it's picking up. In fact, yeah, I'd forgotten that I had problems with this weekend. I didn't need normally the kube proxy. Normally it should pull that address out. It was just when I'd initially tried it Saturday, it wasn't working. And then it fixed itself. Okay, I think I'm good to go. What was I? I'm getting a bit of a mess just by picking just parts of this notebook. Okay, so finally, yeah, I had this object configuration which hadn't been defined. Okay, so yeah, I mentioned contexts. So first it lists the available contexts. We can see that I have one GKE, so it's out in Google Cloud Platform. I have this one Minikube, and apparently I have one called Vagrant. I'm surprised. It's maybe quite an old one. And it's picking up cluster host, the URL. So that was what we saw in the .cube/config. And we can't really see it there, but anyway, the context we're using is this Minikube one. And then, okay, it just looped through the namespaces, looped through the deploys, so it deleted the deploy of my Nginx. We had a replica set that had been created by that deploy, and then it's deleting the pods associated. Okay. So we're not doing a lot yet with Kubernetes API. My intention was to reproduce basically something quite equivalent to what we've done in the command line. It shouldn't be difficult. It's just a matter of time, I'm afraid. Okay. Yeah, in fact, yeah, it is actually, although it's at version 2.0, there's actually, it's actually a Kubernetes incubator project. So on GitHub, that's github.com/Kubernetes-incubator, and then Python client. So yeah, it's relatively new, even though it's at version 2.0. But I think it's that's going to be used going forward. The guy, Sebastian Goaguen of Bitnami, he mentioned to me at the weekend that they've got a Google Summer of Code project around this client. I think they're going to be doing Jupyter notebooks on using this client. So that will be quite interesting to follow. Okay, we've 5 minutes to go. Let me open to questions. I'm sorry we didn't get onto the Apache Mesos, especially as Haïkel has done a lot of work on that. Thank you, Haïkel. But yeah, I'm sorry, but with the networking issues and stuff, it's going to be, it was difficult sticking to schedule. Thanks for sticking with us. Do have a look at the materials when they come online. Any questions? That was Docker Swarm that uses VXLAN between Swarm nodes. I think it does. Actually, there is, it's maybe something you have to enable explicitly. I think that is, yeah. There is, when you do a Docker network create, there is an option -- attachable. And okay, so normally when you create a swarm, if you create another container, which is not in the swarm, it can't communicate with containers running in the swarm unless you actually created a network with this mode attachable that you use for your swarm, and then external entities can connect into that VXLAN network. Okay, good question, especially as I had the answer. Okay, so thanks a lot. And okay, obviously you haven't been able to do much yourselves, unfortunately, but I do encourage you to play with this stuff, and we're very interested in any feedback, any suggestions for moving forward with this. If you do want to do it on your own, then I think you'll find this. There is a lot of usable material there. It's quite interesting. Okay.